Hey Matrix, welcome to the next video in the chemistry playlist. Today we're going over question 7 of the November 2020 past paper. If you don't have the paper, there's a link in the description below where you can go and download the past paper as well as the memo, and once you have the question we can continue with the video. Okay, let's get started with question 7. Okay, so question 7 is the acid and base question for this paper. So question 7 is looking at ethanoic acid, so CH3COOH, is an ingredient in vinegar. Okay. Question 7.1.1 says, is ethanoic acid a weak acid or a strong acid, and give a reason for your answer. Okay, so what I've done here is I've written out the equation and I've broken it up into its ions. Okay, so remember we want to focus on whether it ionizes completely. Okay, that meaning that all the H's separate from the when we break it up. Okay, so if we put this into water and it breaks up into its ions, you can see that there are 3 H's that are still attached there, so therefore it's a weak acid. Okay, and the reason for that is it doesn't ionize completely. Okay, so if it doesn't ionize completely, it's not a strong acid. Okay, now 7.1.2 says an ethanoic acid solution has a pH of 3.85 at 25 degrees. Calculate the concentration of the hydronium ions. Okay, remember the hydronium ions are your H3 plus ions that we're looking for. Okay, so the first thing that should come to mind is the following formula over here, where our pH is equal to the negative log base 10 of the concentration of hydronium ions. Okay, so in order to get rid of the log and get the concentration, we can rewrite the concentration of H3O plus is equal to 10 to the negative pH. Okay, we have the pH, so it's 10 to the negative 3.85. Okay, and that should spit out an answer of 1.41 times 10 to the negative 4 moles per decimeter cubed. Okay, because it's concentration, so it's decimeters cubed. Okay, now 7.3 says that will the pH of the solution, okay, so at the top here it says sodium ethanoate, okay, given over there, forms ethanoic forms when ethanoic acid reacts with sodium hydroxide. Okay, so now it's asking, will the pH of the sodium ethanoate solution be greater than 7 or less than 7? Okay, and the next question asks, explain your answer above and write a balanced equation. So I'm going to do everything at once. I'm going to answer both questions at the same time. Okay, so if we look here, okay, this is the sodium ethanoate. Okay, now what I'm going to do is I'm going to take that and I'm going to react it with water and see what it breaks into. Okay, so by looking over here, when it reacts with the water, we produce the ethanoic acid, which is a good thing because it's something that we want, plus it's produced NaOH. Now the key point here is the OH. Okay, so because we've produced OH over here, we know that this here is basic, and therefore my pH will be greater than 7. Okay, why? Because we formed OH ions, so formed OH ions. Okay, so the balanced equation is given over here. We're reacting it with water. The water splits, the hydrogen comes here, the OH attaches to the Na, and we formed NaOH, which is basic, therefore my pH is greater than 7. Okay, now 7.2 starts with the calculations. So it says household vinegar contains 4.25% ethanoic acid, okay, by volume. Okay, now it says a 1.2 gram of impure sample of calcium carbonate, CaCO3, is added to 25 centimeters cubed of household vinegar. Okay, Then it says, on completion of reaction, the excess, okay, it's in bold, it's important, the excess ethanoic acid in the household vinegar is neutralized by 14.5 centimeters cubed of sodium hydroxide solution of concentration 1 mole per decimeter cubed. Okay, and then they've given us the balanced equation over here. Now, 7.2.1 says calculate the number of moles of unreacted ethanoic acid. Okay, so the key is here, remember the unreacted or the excess ethanoic acid, okay, was neutralized by 14.5 centimeters cubed of sodium hydroxide, plus they've given us the concentration. So if we can work out how much moles of sodium hydroxide, we can then look at the mole ratio here and determine the moles of CH3COOH. Okay, now remember, when we have given an equation here, the only way I can move from one of these to the next one, so let's say I want to move from CH3COOH to this one over here, CH3COONA, I can only do that if I've converted it to moles. Okay, so let's have a look here. We are neutralizing with that amount over there, that's my volume, okay, and they've given me my concentration of NaOH. Okay, so what I want to do is I want to calculate the moles of NaOH, and the quickest way to do that is using your concentration formula. Okay, remember that 1 centimeter cubed is equal to 0.001 decimeters cubed. Okay, so calculating the number of moles here is going to be N of, let's see, it's N of NaOH, okay, is equal to the concentration is 1 mole per decimeter cubed. Okay, then we have the volume here, that's in centimeters cubed, so we convert it to decimeters, so that's going to be 0.00145 decimeters cubed. Okay, that should be a negative. Therefore, we're going to end up with 0.00145 moles. Okay, that's of NaOH. But now remember, if you look at the balanced equation, the mole ratio of NaOH, okay, to CH3COOH, which is what we're looking for, okay, is a 1-to-1 ratio. Okay, therefore we know that N for CH3COOH is going to be in a ratio of 1-to-1, okay, with the moles of NaOH. Okay, so therefore the moles of excess CH3COOH is going to then equal to 0.00145 moles. Okay, now 7.2.2 says calcium carbonate reacts with ethanoic acid, okay, according to the following balanced equation. So they've given us the reaction over here. Okay, it says calculate the percentage of calcium carbonate in the impure sample if 1 centimeter cube of household vinegar has a mass of 1 gram. Okay, so its volume to mass ratio is 1-to-1 if you want to look at it that way. So once again, we can only move between the different compounds if we have their moles, because then we use mole ratios. Okay, so think about these as little islands, and the only way I can get between the islands, so if I want to move from here to here, is with a bridge, and that bridge only accepts you if you are classified as a mole. Okay, so let's have a look at how we're going to approach this. Okay, so the first thing that we need to do is we can assume a 100 gram sample. Okay, now that we've done that, we can work out the mass of CH3COOH, because they gave us that we have, let me just get it over, 4.52% of ethanoic acid, okay? Plus we have the volume of 25 centimeters cubed. So we can work out the mass because of this ratio here, 1 centimeter to 1 gram. Okay, so what I'm going to do is M of CH3COOH, okay, equals to the 4.52% over 100, okay, multiplied by 25 centimeters cubed, okay, and that's going to give us a mass of 1.13 grams. Okay, why? Because 1 centimeter cubed equals to 1 gram. Okay, now once we have that, we can work out the moles. Remember, we need to cross over the bridge with moles. So N equals to M over capital M. So on your periodic table, if you check the molar mass of that, it should be roughly 60. We have 1.13 grams, and that's going to give you moles of 0.01883 moles. Okay, now we have the moles. So remember, we need to take into account the excess, so we need to work out how much actually reacted. So I'm going to minus off this excess that we dealt with in the previous question. So reacted, CH3COOH is equal to 0.01883 minus 0.00145. Okay, and that should give you an answer of 0.0043 moles. Okay, so this is how much actually reacted in our equation. Okay, now we've got how much we have of this. Now we can move to this by our mole bridge, which we use our mole ratio. So we can see it's a 1:2 ratio. Okay, so what we're going to do is we have 0.0043 moles of CH3COOH all over 1 multiplied by our mole ratio. Now what do we want? We want the CaCO3 on top, okay, because that's what we want. So 1 CaCO3 over 2 CH3COOH, okay, and that's going to then half it, which means we get a moles of 0.00217, okay, moles, and this is of CaCO3. Okay, now that we have the moles of CaCO3, we can then calculate the mass, okay, and that is then going to be the mass. Okay, look at your periodic table again. So we'll then have this 0.00217 multiplied by the molar mass, which is then 100, okay, and that's then going to give you 0.217 grams, okay, and because they wanted the percentage of the mass, the percentage of CaCO3, okay, remember in the beginning they told us that a total of 1.2 grams of impure sample of calcium carbonate was used, okay, so that's my total. So then I'm going to have this 0.217 grams all over 1.2 grams, okay, and if I then times that by 100, I'll then get 18.08%. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. It does help a lot. If you have any questions regarding question 7, please leave them in the comment section down below, and I'll get back to them as soon as I can. Please go check out the YouTube channel. There's physics and maths paper, past paper questions as well. While you're there, please consider subscribing to the channel. And remember, it's never too late to have an OIC moment.